Humanity has always looked up at the night sky and wondered one simple question. What is out there? For thousands of years, the planets were mysterious lights moving across the darkness. Then we discovered they were worlds, rocky planets, gas giants, ice giants, moons, rings, asteroids, comets. But eventually, another question became even bigger. The answer is not empty space. Beyond our solar system is one of the most mysterious regions humans have ever tried to understand. A dark frontier filled with icy worlds, invisible boundaries, ancient comets, cosmic radiation, and the first human-made spacecraft ever to escape the sun's protective bubble. This is the journey beyond the solar system. Our story begins with the sun. The sun is not just the center of the solar system. It is the force that holds everything together. Its gravity controls the motion of planets, dwarf planets, asteroids, comets, and countless icy objects billions of miles away. But the sun also sends out something invisible, a constant stream of charged particles called the solar wind. This solar wind flows outward in every direction, creating a huge protective bubble around the solar system. This bubble is called the heliosphere. Inside the heliosphere, the sun still has influence. Its particles and magnetic field push against the dangerous radiation coming from deep space. But this bubble does not go on forever. Far beyond the planets, the solar wind begins to slow down. It becomes weaker. The pressure from interstellar space becomes stronger, and eventually the sun's protective bubble ends. That boundary is called the heliopause. Crossing the heliopause means entering interstellar space, the space between stars. But before we reach that boundary, we must travel past the most distant planets. First, we pass Mars, Jupiter, Saturn, Uranus, and Neptune. Neptune is the farthest official planet from the sun. It is a cold, blue ice giant with supersonic winds and a deep atmosphere of hydrogen, helium, and methane. For many people, Neptune feels like the edge of the solar system, but it is not even close. Beyond Neptune is a vast region called the Kuiper Belt. The Kuiper Belt is a massive donut-shaped zone filled with icy objects left over from the formation of the solar system. This is where Pluto lives. It is also home to many other dwarf planets and frozen bodies that have barely changed for billions of years. Imagine a giant ring of ancient ice and rocks surrounding the outer solar system. That is the Kuiper Belt. Pluto was once called the ninth planet, but today scientists classify it as a dwarf planet. And Pluto is not alone. It is part of a much larger population of icy worlds orbiting far from the sun. In 2015, NASA's New Horizons spacecraft flew past Pluto and revealed something astonishing. Pluto was not a dead, frozen rock. It had mountains made of water ice, vast plains of nitrogen ice, possible underground activity, a thin atmosphere, and a heart-shaped region that became one of the most famous images in modern space exploration. Then New Horizons continued deeper into the Kuiper Belt and visited an object called Arrokoth, one of the most distant and primitive objects ever explored by a spacecraft. But even the Kuiper Belt is not the final edge. As we keep moving outward, sunlight becomes weaker and weaker. The sun still looks bright, but it no longer dominates the sky the way it does from Earth. The planets become invisible without powerful telescopes. The solar system begins to feel less like a family of worlds and more like a tiny island in a vast black ocean. Then we reach the outer region of the heliosphere. This is where things become strange. The solar wind, which has been racing outward from the sun, begins to slow as it crashes into material from interstellar space. This region is called the heliosheath. It is not a solid wall. It is not something you could see with your eyes. It is a turbulent zone where particles and magnetic fields interact at the edge of the sun's influence. And then comes the heliopause.
The heliopause is one of the most important boundaries in space exploration. It marks the place where the solar wind can no longer push outward against the interstellar medium. On one side is the sun's domain. On the other side is interstellar space.
For most of human history, this boundary was only theoretical. Then Voyager 1 reached it. Voyager 1 was launched in 1977. Its original mission was to explore the outer planets, especially Jupiter and Saturn. But after completing its planetary mission, it kept going. Year after year, decade after decade, it moved farther from Earth. Then, in 2012, Voyager 1 crossed the heliopause and became the first human-made object to enter interstellar space. Voyager 2 followed in 2018. These two spacecraft are now traveling through the space between stars. They are incredibly far away. Their signals take many hours to reach Earth. And yet, after nearly half a century, they are still part of one of the greatest missions in the history of science. Voyager 1 and Voyager 2 are not traveling toward another star in any practical sense. They are moving through interstellar space, but stars are so far apart that even at incredible speed, the journey would take tens of thousands of years. This is where the true scale of the universe begins to appear. On Earth, distance feels large when we talk about miles or kilometers. In space, those numbers become almost useless. The distance from Earth to the Sun is called 1 astronomical unit, or AU. Neptune is about 30 AU from the Sun. The Kuiper Belt begins around Neptune's orbit and stretches far beyond it. Voyager 1 crossed into interstellar space at about 122 AU from the Sun. But even that is not the final boundary of the solar system, because there is another region even farther away. A mysterious shell of icy bodies known as the Oort Cloud. The Oort Cloud has never been directly photographed. Scientists believe it exists because of the behavior of long-period comets. Comets that fall toward the Sun from extremely distant, stretched-out orbits. Unlike the flat disk of the planets in Kuiper Belt, the Oort Cloud may surround the solar system like a giant sphere, a vast shell of icy leftovers from the birth of the Sun. Some of these objects may be disturbed by passing stars or the gravity of the Milky Way. When that happens, they can begin falling inward toward the Sun, becoming comets that appear in our skies after journeys lasting thousands or even millions of years. The Oort Cloud may extend a huge distance from the Sun, possibly a quarter to halfway to the nearest star. Think about that. The solar system may not end with Pluto. It may not end with the Kuiper Belt. It may not even end with Voyager crossing into interstellar space. The gravitational reach of the Sun may extend into a distant cloud of icy worlds so far away that the nearest stars begin to matter. And beyond that, the next great destination is another star system. The closest star to the Sun is Proxima Centauri, part of the Alpha Centauri system. It is about 4.25 light-years away. A light-year is the distance light travels in 1 year. Light moves at about 186,000 miles per second. Even at that speed, it takes more than 4 years to reach Proxima Centauri. For a spacecraft like Voyager, the journey would take tens of thousands of years. And yet, Proxima Centauri is our nearest stellar neighbor. That tells us something profound. The space between stars is enormous. It is not crowded like science fiction often shows. Stars are separated by distances so massive that human language struggles to describe them. Between the Sun and Proxima Centauri, there may be dust, gas, cosmic rays, magnetic fields, dark objects, rogue planets, ancient comets, maybe even objects ejected from other solar systems. But mostly, there is distance. Vast, silent distance. And then, after the nearest stars, we begin to see the greater structure we belong to, the Milky Way galaxy.
Our solar system is not floating alone. It is orbiting inside a galaxy that contains hundreds of billions of stars. Every star may have its own story. Some may have planets. Some may have asteroid belts. Some may have icy outer regions like our Kuiper Belt. Some may have worlds with oceans. Some may have planets completely unlike anything in our solar system. Our Sun is just one star among hundreds of billions, located in one spiral galaxy among countless others. And beyond the Milky Way are more galaxies: the Andromeda Galaxy, the Triangulum Galaxy, galaxy clusters, superclusters, cosmic filaments stretching across the universe like a web. The farther we zoom out, the smaller our solar system becomes. Earth becomes invisible. The Sun becomes one ordinary star. The solar system becomes a tiny point inside a galaxy so large that light itself takes about 100,000 years to cross it. And the Milky Way becomes just one galaxy in a universe filled with trillions of galaxies. This is what lies beyond the solar system. Not an edge, not a wall, not emptiness, but layers of cosmic structure. First, the outer planets, then the Kuiper Belt, then the heliosphere, then interstellar space, then the Oort Cloud, then nearby stars, then the Milky Way, then the universe beyond. But there is one more part of this story that makes it deeply human. Somewhere out there, traveling in the darkness, are Voyager 1 and Voyager 2. Tiny machines built by humans on a small planet. They carry instruments, memories, and golden records containing sounds and images from Earth. They are moving away from us forever, long after their power fades, long after they stop sending signals, long after every person who built them is gone. They will continue drifting through space, silent messengers from a world called Earth. And perhaps millions or billions of years from now, they may still be out there, relics of a civilization that looked up at the stars and dared to ask, what lies beyond? The answer is bigger than we imagined. Beyond the solar system is not the end of the story. It is where the real universe begins.